Hello everyone, welcome first year students English section, Faculty of Commerce, Sarat City University. This is Reem Sobhi. I'm a teaching assistant at Insurance Statistics and Mathematics Department. This is section 10 in pure mathematics course on chapter 4 titled Exponential and Logarithmic Equation. In this section, our learning objectives is to learn the properties of logarithms and solve logarithmic equation. Properties of logarithms. In section number 9, we illustrated the properties of logarithms in details, and you can go back to this section in order to revise these properties. In this section, we can abbreviate these properties in general form for the logarithm. The logarithm consists of two parts: the base of the logarithm and the number that we want to take the logarithm for. The base of the logarithm consists of three types, or can take three cases. The first one, the base of the logarithm can be 10, and this is called the common logarithm. Another case or another type, that the base of the logarithm can take any real number which is equals to b. And the third case, that the base of the logarithm equals to e, and this means the natural logarithm, or called the natural logarithm, and e equals to 2.7183. So this is the common form of the logarithm, and e is the natural logarithm, and b can be any real number for the base of the logarithm. So these are the three types of the base of the logarithm, and this is the number that we want to take the logarithm for. For any type of the base of the logarithm, we have three main properties. When when the number of the logarithm takes 1, this means the logarithm equals to 0 for any type of the base. And when the number of the logarithm equals to the same base, example, when the base equals to 10 and the number equals to 10, this means that the logarithm to the base 10 for 10, this means 1. Also, logarithm for base b for b equals 1. Also, len e equals 1. So, when the base and the number are the same, this means that the logarithm equals to 1. Another property that when we said that log for b powers x for any base 10 or b or e, this means that we bring the x before the logarithm, so this equals to x times log b. When the base is equals to b, then b for b, this means 1, so this equals to x. When x times log for the base 10 for 10, this means x, as this quantity equals to 1. When we said x times len for e, this quantity equals to 1, and this equals to x. When we said 10 power log x, this means the base here equals to 10 also. So 10 power log 10 equals to 1. So this equals to x. Again, when we said b power log b to x, this means b goes with log b, so this equals to x. And for the for e, when we said e power len x, this equals to len goes with e equals to x. So briefly, this is the main properties of logarithms. Also, we have three common rules, which is product rules and quotient rules. When we have two quantities multiplied with each other with the same logarithm, then This means these quantities are added to each other. Log m times n means log m plus log b. The quotient rule means when we have two quantities divided with each other, this means log m minus log n. Let's solve some examples in order to clarify these properties. Example, given the following logarithmic equation, log 2x equals to 2, find the value of x. We need the value of x here. In order to solve this equation, we can recall the property of the logarithm, which says that log x for the base b equals to y means x equals b power y. And in this case, the base here is not written, and this means it's 10. So log 2x for the base 10 equals to 2. And by taking the base of the log, so 2x equals 10 power 2. The base of the log would be on the right hand side and takes the power 2, which is the constant on the right hand side. And this equals 2x equals to 100, then x equals to 50. So the correct answer is A. Again, let's have another example. For the following logarithmic equation, find the value of x. Here, log for the base 2 for 4x minus 1 equals to minus 3. Again, by using the property says log x for the base b equals y. This equals x equals b, the base, power y. By using this property and applying this on this logarithmic equation, we can get log 2 for 4x minus 1 equals minus 3. By giving the base of the logarithm the power minus 3, this would equal 4x minus 1 equals 2 power minus 3. And again, recalling the property of exponents that says that when we have b power minus m, this means 1 over b power m. So in this example, we have 2 power minus 3, and this means 1 over 2 power 3. And 2 power 3 equals to 8, so 1 over 8. So again, by going back to the example, 4x minus 1 equals 1 over 8. By taking negative 1 to the other side with different sign, so 4x equals 1 over 8 plus 1, which means 1 means 8 over 8. And this equals 1 plus 8, 9 over 8. So x, 4x equals 9 over 8. We only need x, so x equals 9 over 8 by over 4, and this means 9 over 8 times 1 over 4. So x equals 9 over 32. So the correct answer is A. Another example, given the following logarithmic equation, log to the base 5 for x minus 4 plus log for the base 5 for x equals to 1. In this example, we have two logarithmic added to each other, and by recalling the property that says that when we have log for m plus log for n, this means we log m times n. By applying this property on this example or in this equation, we get that we have log 5 for x minus 4 plus log 5 for x, and this equals to 1. This means log 5 for x minus 4 times x equals to 1. So log 5x x minus 4 equals to 1. And again, by recalling the property that says that log b for x equals y means x equals b power y. We can apply this property for this example. So x times x minus 4 equals, taking the base of the log and give it the power of 1, equals to 5 power 1, which means 5. So x equals to 5 and x minus 4 equals 5. So, and this means x equals to 9. By substituting with the values in the example and find and check the answer, we can see that 5 minus 4 equals to 1, and log 5 for 5 means equals to 1. So log 5 for 1 equals to 0. 5 minus 4 equals to 1, and log 1 for the base 5 equals to 0, and log 5 for 5 equals to 1. So 0 plus 1 equals to 1. So this is correct. For 9 minus 4 equals to 5. Then log 5 for 5 equals to 1, plus log 5 for 9. This would not equals to 1, so we reject x equals to 9, and the correct answer is x equals to 5, and the correct answer is B. Again, another example. For the following logarithmic equation, log for x minus 3 plus log for x plus 4 equals log 4 for x. Again, by using the property of logarithmic, that's log for m plus log n, this equals to log m times n. So log x minus 3 times x plus 2 equals log 4x, and log goes with log, so x minus 3 times x plus 2 equals 4x. By multiplying both quantities, we get x square, x times x, x square, and x times 2, 2x, minus 3 times x, minus 3x, and minus 3 times 2 gives minus 6. This equals to 4x. So x square, 2x minus 3x minus x, and by taking 4x to the other side with different sign, minus 4x minus 6 equals to 0. So x squared minus 5x minus 6 equals to 0. This is the form of a quadratic equation, and we can solve this equation using factoring. So x and 6, 1 times 6. So by giving 1 a positive sign and 6 a negative sign, 1 times negative x means negative 6, and 1 minus 6 minus 5x. So x plus 1 times x minus 6 equals to 0. So x plus 1 equals 0 and x minus 6 equals to 0. So x equals to minus 1 and x equals to 6. By substituting the values of x in the original equation in order to check the answer, so minus 1 minus 3 gives minus 4, and we don't have logarithm for any negative values, as this is undefined. And here again, minus 1 plus 2 gives log 1, and log 1 equals to 0, and minus 1 times 4 gives minus 4, and there is no logarithm for any negative numbers, so we reject this answer and accept x equals to 6, as 6 minus 3 equals to log 3 plus 6 plus 2 log 8 equals to 6 times 4 log 24. And the correct answer is C. Another example, for the following logarithmic equation, find the value of x, again by using the rule that says that log m plus log n equals to log m times n. So we can say that log 2x minus 5 times x minus 3 equals to 1. This means there is no base here for the log, and this means it is equals to 10. So 2x minus 5 times x minus 3 equals to 10 power 1. By multiplying both brackets, we get 2x squared minus 6x minus 5x plus 15 equals to 10. So 2x squared minus 11x, and by taking 10 to the other side with different sign, and this would equals to plus 5 equals to 0. This shape of equation cannot be solved using or we can use factoring method, x and x. Let's try 1 and 5 and 2x, so plus and or minus and minus, so 2x times minus 5 gives minus 10x, and minus x gives us minus 11x, and minus 1 times minus 5 gives plus 5, so this is correct. So by using factoring method, we can solve this quadratic equation, and this would equals to 2x minus 1 times x minus 5 equals to 0. So 2x minus 1 equals to 0, and x minus 5 equals to 0. So 2x minus 1 equals to 0, so x equals to half, and x minus 5 equals to 0, so x equals to 5. Let's substitute the values, and here first by using half. So 2 times half gives 1, so 1 minus 5 means 4 minus 4, so there is no logarithm for negative numbers, so this is not defined. And also a half minus 3 also gives negative value, so 2 and minus 2 and half, and also there is no logarithm for any negative value, so we reject this value of x, and we accept x equals to 5. There is a problem here in the choices. We can make b equals to x equals to 5 and choose b as the correct answer. Given the following logarithmic equation, ln x squared minus ln 9 equals to 0. Again, recalling the property says that when we have ln m minus ln n, this means ln m over n. So for this equation, we can say that ln x squared over 9 equals to 0. Again, recalling another property which says that when we have ln x equals y, this means x equals e power y. So in this case, we can say that x squared over 9 equals e power 0, and e power 0 equals 1, so x squared over 9 equals to 1. So by multiplying both sides, we get x squared equals to 9. By taking the square root for both sides, then x equals plus or minus 3, and the correct answer is A. Another example, given the following logarithmic equation, find the value of x. Again, recalling the property says ln x equals to y means x equals to e power y. So in this equation, we can find the value of x using this property, and then x squared equals e power 5. And by taking the square root for both sides, we get x equals to plus or minus square root of e power 5, and the correct answer is C. Another example, given the following logarithmic equation, ln of x squared plus 1 equals 4. Again, using the property ln x equals y means x equals e power y. So x squared plus 1 equals to e power 4. Then x squared equals e power 4 minus 1, as we take 1 to the other side with different sign, and by taking the square root of both sides, we get x equals to plus or minus square root of e power 4 minus 1, and the correct answer is B. Another example, given the following logarithmic equation, log 2 minus 3x plus log 3 minus 2x equals 1.5. And again, by recalling the property says when we have log m plus log n, this means log m times n. So log 2 minus 3x times 3 minus 2x equals 1.5. And also recalling another property which says that when we have log x for the base b equals y, then x equals b power y. So in this example, the base equals to 10. So 2 minus 3x times 3 minus 2x equals 10 power 1.5. And then by multiplying both brackets, we get 6. 2 times 3 equals 6. 2 times minus 2x equals 4, minus 4x. And minus 3x times 3 gives minus 9x. And minus 3x times minus 2x gives 6x equals to 10 power 1.5. And this equals to 6 minus 4x minus 9x plus 6x gives minus 7x. So 6 minus 7x, so this is x squared, sorry, minus 4x minus 9x gives minus 13x plus 6x squared equals to 10 power 1.5. And this can be rewritten as 6x squared minus 13x plus 6 minus 10 power 1.5, and this quantity approximately equals to 26. So we can say that 6x squared minus 13x plus 26 equals to 0. This is the form of quadratic equation, and we can solve this using the general quadratic form, which says that minus b plus or minus square root of b squared minus 4ac over 2a. And by substituting the values of b, a, and c, we get 13 plus or minus square root of minus 13 square minus 4 times 6 times 26 over 2 times 6 equals to 12, and this equals to 13 plus or minus square root of 793 over 12. So the correct answer is D. Another example, given the following logarithmic equation, ln x plus ln x minus 2 equals to 4. Again, recalling the properties, says that when we have ln m plus ln n, this equals to ln m times n. And when we have ln x for y, this means x equals e power y. By using these properties, we can solve this equation, ln x plus ln x minus 2 equals 4, as following: ln x times x minus 2 equals to 4, and then x times x minus 2 equals to e power 4. We can extract these values by x squared minus 2x minus e power 4 equals to 0. And again, by using the this is a quadratic equation, and by using the general form of quadratic equation, minus b plus or minus square root of b squared minus 4ac over 2a, this equals 2 plus or minus square root of minus 2 squared minus 4 times a, which is 1, times c, which is a power 4, over 2 a, and this equals 2 plus or minus square root of 4 minus 4e power 4 over 2. And the correct, sorry, this is minus, and this would equals to plus, and this minus e power 4, so this is plus, and the correct answer is A. Thank you for watching this video and sharing your time with us. Hope it's useful to you. See you at the next video, and good luck to you all. Goodbye.